Okay, that stuff, those last couple in this second standard, now we're going to apply this to some material. Okay, I need to present some information before we start the problems. We did these in Algebra 1, but I need to re-present it so it makes sense. Now I want you to look at this. A go-kart track charges a $50 membership fee and $35 to race. Complete the following table with the information. Alright, so if they don't race at all, they paid the $50 membership fee. That's why on those lines, you know, X comma Y, X is 0. Well, that'd be your initial fee, $50. Then if you race once, well, 35 plus 50 is 85. If you race twice, you take 35 times 2 plus 50, 120, 55, 90. And that's why this is a linear function, okay, if graphed. Now this one right here is different. A go-kart has 380 racers and charge $35 to race. For every $1 decrease in price, 20 more racers will come. Complete the following table, which I've done for you. Okay, so when they're if they're charging $35 to race and there's 380 racers, each racer pays $35. 35 times 380 is $13,300. That's how much money the track made. Now, if they drop the price by $1, it goes to $34, but then 20 more racers come because the idea is it's cheaper. So 34 times 400 is 13,600. So the price, it went up. Drop it again by $1, 33 times 420, because it goes up by 20. That's 13,860. Went up again. 32 and then up 20. So if this goes down by 1, this goes up by 20. Okay, you can see that on your paper. 14,080 went up. Okay, I repeat the process. It went up again. It went up again. It went up again. Went up. Went up. Oh, it went down. Okay. So it hit a high point right here. Okay. Circle that high point where it's the highest. And then it starts going down. So that is a parabola. Now, what's the difference in values between the generated and the second column for each table? Well, this one just kept going up. That's all you need to write, kept going up. And this one went up, hit a peak, went down. Okay, why do the values generated in the second column and the second table behave the way they do? Now think about that in street terminology. How come eventually they're not going to make as much money if they keep dropping the price by $1? Well, eventually I go down $1 enough times, they're going to be giving away the races for free. So eventually, races will be free, meaning no money. Okay? And if you had to graph, what would they look like? I already wrote that down. Line on the first parabola, but we're concerned today with the parabola. Okay. Now I want you to write some real quick thing on the back side. Let's say I sell 10 hot dogs or whatever, and I sell them for $2 each. What's the revenue I'd make? 10 hot dogs, $2 each, probably 20. How did you get that? Well, you took the money multiplied by the items sold. And this is the formula we will use for revenue, because the problems we're going to be doing are a lot more complex than that. Okay? Okay, now here's a new type of story problem. A go-kart has 380 racers and charges $35 to race. For every $1 decrease in price, 20 more racers will come. How many times should the store decrease the price by $1 to maximize its revenue, and what will the maximum revenue be? Well, you're finding the maximum revenue. The way to find a maximum is to make this huge parabola in the middle. Don't mess around with any boxes, okay? You're going to find the maximum, mark that point off, and there is an x and a y that we need to find, okay? The y is actually the answer down here. Now, if you remember that graph, okay, the formula for the x, because this is we want standard form. We want to end up with an equation in standard form with the ax squared bx. So, because I know the way to find the maximum x point is the opposite of b divided by the product of 2 and a. Okay, so we need to get an equation here. This is revenue. So you get, with parabolas, you have to know how to write the equation, okay? Revenue would be the money we charge times the items sold. Now I'm going to pause for a second so get your mind processed. I'm going to relax for about 10 seconds. Maximum in algebra has an x and a y. The way to find the x is opposite of b over 2a. And the way to find that y is to replace x in the equation. Okay, you are not done till these two have values. And there's revenue. Revenue is money times items sold. Okay, now let's teach you how to write the equation. First thing you want to do is put a parentheses for the money, and each one of these factors gets a parentheses. And the first thing we're going to do is replace the r with y. Okay, why is that? Because I like y there. I'm used to having y there. And then I make two parentheses, and we're going to fill these in with some values. So what's going on with the money? Circle the money amounts. Okay. Well, we got $35, and we got $1. This $1 here is just a repeat of the same information. Those two go together. They're like terms. So we started with $35, and then what did we do? We decreased it by $1, so minus 1. However, remember on that last table, we kept decreasing it by 1 over and over? Well, since that happened over and over, we connect an x variable on that. Okay, and x represents the number of price changes. Okay, now cross those out. And now, what are the items we're selling? Races. So we have 380 and we have 20. Those are like terms. So 380, and it says 20 more. So plus 20 with x. You got to pay attention to your signs that you're putting in there. Okay. All right, now. That's great, but the problem is this isn't in standard form, okay? I need to get this out of factored form, because right here it's in factored form with the two parentheses. We need to get this in standard form, okay? So y equals blank x to the second plus blank x plus blank. And this is going to be my A, this is my B. Okay, now the question is, how are we going to multiply this out? Well, FOIL, okay? You're going to take 35 times 380. I'm going to put this up here. You're going to take 35 times 20x. It's a little bit time consuming. You're going to take negative 1x times 380. And you're going to take negative 1x times 20x. That's a negative 1. Remember that. Okay, so I take 35 times 380, and that's going to be 13,300. I'm going to take 35 times 20, that's 700. One of the factors has x, so it's 700x. Negative 1 times 380 is negative 380. One of the factors has x. Okay. Negative 1 times 20 is negative 20, and that has x to the second. Okay. All right, so x squared, what do we got? Well, we got negative 20. That's my A. My B, well, x's, we would take these and add them. 700 plus negative 380, that's going to be 3. That is going to be 320. And then 13,300. Okay, so right here, now we have my A and the B. Okay, and now I can come up here and fill. Remember, you're not done until we have these right here. If you know where do I stop, you stop when you find these values. So now I know the opposite of B is negative 320. And 2 times A. 2 times A is negative 20. Okay, and that gives me a negative 40. So I'm going to cross that out and put negative 40 and then divide. Okay, and that ends up being 8. Okay, so there were 8 price changes. We went down by $1 8 times. That's what that represents. And now to find the y, we replace x in the equation down here. Okay, so I'm going to put 8's right there. So I take negative 20 times 8 to the second power plus 320 times 8 plus 13,300. 14,580. All right. And that's your maximum revenue, $14,580. Yeah, the problem is a little bit time consuming, not gonna lie. All right, next one. Video store sells about 150 DVDs at a price of $20. The owner estimates that for each $1 decrease in price, about 25 more DVDs will be sold each week. How many price changes should occur for the store to maximize revenue? And what will the maximum revenue be? The X is the number of price changes, okay? Now again, maximum, I don't worry about units. I go right to my parabola. Okay, and I know there's an X and a Y I need to find, and the X is found with the opposite of B divided by 2 times A. And the Y is found by replacing X in the equation, because Y equals that. That's why it's important to have the Y equals out front so you know where you're looking. Okay, so the revenue. Revenue is equal to the price I charge times the items that I sell. Okay. Revenue is Y. And we're going to put a parentheses around each factor. Now you need to go look for money amounts. You have 2 of them. You have $20 and you have $1. Those are like terms. So we start with 20. And then it's a $1 decrease, so it'd be you got to pay attention to whether it's a plus or a minus, okay? So minus 1, and that's happening over and over, so that would be X, 20 minus 1X. Okay, now let's look for our items. We're selling DVDs, so I have 150 DVDs and 25 DVDs. So those are like terms. We start with 150, and it's 25 more, so plus 25 with X, okay? So the equation's down. Well, that's great, but it's in factored form. I need to have a standard form, so I use the FOIL method. So Y equals blank X squared plus blank X plus blank. And what I'm actually going to do is make a little box down here to do my FOIL work. So 20 times 150 and 20 times 25X. That's done. Negative 1X. You got to get the negative on the 1 or you're screwed. Okay. Negative 1X times 150. I mean, you're going to get an answer that's totally messed up if you don't get that negative. Okay. Negative 1X times 25X. Okay, so this is 3,000. No X on that. That's going to be 500 with X because one factor. It's going to be negative 150 with X, and that's going to be negative 25, and since both factors have X, it goes to the second power. So for X second, we got negative 25. For X, we add, that's out, and then we add these two together, and it's 350. And then plus 3,000. Okay, and now I have my A and my B. Okay, so the opposite of the B is negative 350. And then 2 times the A, so 2 times negative 25. That's going to be negative 50. And then divide, and you get 7. Okay, so 7 is the number of price changes. Okay, and now to find the maximum revenue, we're just going to insert 7 because y equals this. Well, I know if the x is 7, it should be pretty easy to find y if I can replace all those x's with 7. $4,225. Okay. Next problem. I'm going to go over one more. They're cookie cutters, okay? You just gotta, that means they're all kind of work the same. An online music store sells, the reason I do this, because I think it's important you apply the stuff to actual word problems, okay? Rather than just having you do numbers and letters. An online music store sells about 4,000 songs in a set time when it charges $1 per song. For each 5-cent increase in price, 80 fewer songs are sold during this time. How many price changes occur before the store reaches its maximum revenue? What will the maximum revenue be? So again, whenever you're finding a maximum, this is the go-to, okay? And again, the maximum xy, and opposite of b, divided by 2 times a. And then find the y, we replace x on the calculator in the equation. That's how you find any max. Now write the equation. This is a revenue problem, so the revenue equals the dollars multiplied by the items that we sell. Okay, get r out of there and put y in. And then each factor needs a parentheses. So the money, I have $1 and I have 5 cents. So I got 1, and it says 5-cent increase. So plus 0.05 with X, because we go up from $1 to $1.05 to $1.10, and this leads to less people buying because we're upping the price. Okay, items, we got 4,000, and then 80 fewer, so minus 80X. Okay. Problem is, we got to get rid of these parentheses if we have a b and an a, logically. Blank x squared plus blank x plus blank, put a and b so you know where to look when you find those. Okay, FOIL box, 1 times 4,000. Now, some of you are like, I don't remember this being that much work. Yeah, because I let you use a program called the Math Papa Algebra Calculator. You're not using that until second semester. Okay, you use GCF calculator when we get to it, but the math, you should need to be able to FOIL that out. It's not hard. Okay. Basically, I was at the end of the year and I just wanted to get through it. Remember, the 80's negative. I mean, if you use your phone to do it on your own time, whatever, you ain't going to use it on the test, so you might as well practice it. Okay, so 0.05x times negative 80x. Okay, so that's 4,000, and that's negative 80x. The people who mess this up are the ones that miss that negative on that. And there's always a negative somewhere. You got to know where it's at. Okay, this is going to be 200 with x. Not sure how I did that right in my head, but you need to use a calculator. Okay, and this is negative 4 with x to the second. Okay, so x second's negative 4, so we got the a. Now the b, we need to add these two guys together. So that's 120 and then 4,000. Okay, so the opposite of b would be negative 120 and then 2 times a, so 2 times negative 4. That's negative 8, and I divide the two negatives. You should always end up dividing a negative by a negative on these story problems. Okay, that's 15. So that's 15 price changes, and that's why you don't want to make a table and just do trial and error. That would take forever. And now we're going to put 15 in for these. Okay, so negative 4 times 15 to the second plus 120, parentheses 15, plus 4,000, 4,900. Okay, so 4,900 is the maximum revenue. Again, the 15 is the number of price changes it takes to make that maximum revenue. That's where you max out at. Okay, that's all I have to say on that. Hope it's been informative. You have one problem, do on your own. If you have any questions, let me know.